Okay, let's talk about acceleration. Well, first of all, acceleration is equal to the change in velocity divided by time. And another way of writing that is VF minus VI over T. Also, in addition to VF minus VI, you may, as you're looking and trying to understand this, you may see it sometimes written as V1 minus V0 over T. In either cases, these are representing the final speed, and this is representing an initial speed. Again, I'll probably use this, but both of them are fine to use. Now, as long as you have one equation and one unknown, you can solve it. So any one of those three things can be an unknown. Now, there's keywords you want to look for that will help you. Things like rest, stop, come to a halt, anything in which the object is going to stop, because what that's going to tell you is one of the speeds will be 0. If it's going from rest, VI is 0. If it's going to rest, VF is equal to 0. So again, that will kind of help you understand that a little bit as you do the word problems with this stuff. And again, right now we're only talking about constant acceleration. Changing accelerations are not covered in this class. Now, changing acceleration you may feel, and there's even a word they're starting to use for it, it's called the jerk. Because your body jerks when you have a great change in acceleration. So you may want to keep that in mind for the future, but we're not going to deal with it. All we're going to deal with constant acceleration. Now let's take a look at the units real quick, because the units are something that bothers sometimes people. A is equal to delta V over T. Well, delta V is going to be in meters per second. Time is going to be in seconds. Now, if you want to leave it as meters per second right now, I'm okay with that. It's the same as meters per second squared, but I'm okay if you leave it this way, because to be honest with you, it helps you understand it. So let's say a car has an acceleration equal to 4 meters per second each second. If I make a graph of time versus speed, not a graph, table, and we're going to say it started at rest, so 0, 0. After 1 second, it's now going 4 meters per second. After 2 seconds, it's going 8 meters per second. After 3 seconds, it's going 12 meters per second. Now, if you take a look at this, in each second, the speed changed 4 meters per second. So therefore, this kind of makes sense if you say it this way. The speed changed 4 meters per second each second. Okay, now let's look at where direction comes into effect with acceleration. So if I get VF minus VI over T, and that is greater than 0, in other words, it's a fancy way of saying it's positive, what that means is that you're speeding up. And that's our familiar way of using acceleration. If I get A equal to VF minus VI divided by T, and it's less than 0, that's a negative acceleration. That means you're slowing down. Now, to tie this back to what we've already talked at, this only happens if I have an unbalanced force. So in other words, I have to have a net force in order for this to happen. Okay, let's do an example. Jill goes from rest to 6 meters per second in 3 seconds. What is her acceleration? Well, whenever you're doing word problems, and we'll start doing more word problems, what you want to do is write down the stuff you know. You want to make a list of your givens and your unknowns. So now, Given. Well, that tells me something. Rest means that the initial speed is equal to 0. The final speed is 6 meters per second because I'm going to that speed. And then, of course, 3 seconds, that's the easy one, times 3 seconds. The next thing you want to do is also now write down what your unknown is. Well, your unknown is acceleration. The reason you want to do that is because, quite literally, you could cover up all 4 of those. As long as you only have one unknown, it's solvable. Well, we know that our basic equation is this, VF minus VI over T. I would do any algebra you need to do before you solve it. This is already done algebraically because you're looking for A, so you don't have to rearrange it. A is equal to 6 meters per second. Notice how I leave the units in, minus 0 divided by 3 seconds. Well, do the math. 6 divided by 3 is 2, and it's positive. Now, do the same thing with the units. Meters per second divided by seconds. Now, if you want to write it this way, I'm okay with that. If you want to write it as 2 meters per second squared, I'm okay with that too. I can live with it either way. Let's do a second one. Jill sees a bear and stops in 1 second. And this is related to this problem up here. She stops in 1 second. What is her A? What is her acceleration? Well, now again, we'll go with givens and unknowns. In this case now, her initial speed is 6 meters per second. Because we assume it's related to this problem, so she's already going the 6 meters per second, which you can't see, it's off screen. It's up there, right there. Her final speed now is 0 because she stops. Time is 1 second. A is our unknown. A is equal to VF minus VI over T. Now I have 0 minus 6 meters per second divided by 1 second. Negative 6 meters per second squared. That negative sign is important. It's telling you that she's slowing down. Cool. Hope this helped. We'll play with this stuff some more.